Hello everyone, this is Giannis with Ververica, and in this video we are going to talk about the stock trading markets, and in particular we are going to see how Ververica and Apache Flink and stream processing in general can help you in those markets quickly analyze events and make sense out of them. So why the stock trading markets, right? So picture this. You're on a bustling trading floor with monitors flashing price updates every millisecond or second. Traders huddle around terminals ready to make split-second decisions that could swing millions of dollars in profits or losses. In such high-stake environments, data speed is everything. Stock markets generate an immense amount of data every second. If your system lags, you're already behind. Delays in spotting trends or detecting anomalies can cost you big. And real-time insights there is not just a nice to have, and it's really important to get it right. And this is where streaming data platforms like Ververica's unified streaming data platform that builds on Apache Flink, which is the de facto standard for stream processing, comes into place. It offers an edging built for low latency, high throughput analytics. And in stock trading, it enables real-time trade execution, risk monitoring, and anomaly detection, and all these things with millisecond level precision. Now, all these things are really important because it allows you to do sub-second decisions. You can capture all the market movements as they happened and make sense out of those. It can help you identify anomalies in real time, like identifying the fraudulent trades and the market manipulation. It allows to scale with ease, like process massive trade volumes across global industries, and also power AI-driven trading, right? You can feed real-time data into machine learning models for smarter and real-time decision making. Now, all these things sound good, so we're going to see here, we're going to present a demo playground with things you can try out yourself and build some applications to help us understand better how these things work. We're going to build our applications with Apache Flink and also deploy them on Ververica. So I'm going to go back to my IntelliJ IDEA here. And we have this data generator here that generates data for different kinds of events. We have stock events that are being generated, we have trader information that are being generated, we have trade orders for orders that traders place for specific stocks, and we also have market events. And these market events can influence the price of stocks, right? Depending on the event and what happens to the market, stock prices can go up or they can go down. And basically, the data generator is here, and you can use it with this Kafka producer here to send your data to Kafka, and we will be consuming out of those. And here we have 4 different jobs to do various different things. So the first job we're going to see is the market analysis impact job we have here. So what we are trying to achieve here with this market event analysis. This is designed to evaluate in real time the effects of the market events on stock prices. By processing continuous streams of market events and stock price data, what this application allows you to do is to provide valuable insight into how specific events influence stock prices. So for example here, and in this particular job, I'm having mock data for the data streams like finite sources, only because when playing with random data, it's sometimes hard to trigger the right effect. So for that, in this specific job, I'm using some sample data here. And what we are doing is we have basically 2 input data streams here about the market event streams and the stock price data. We're running the key buy operation to partition both streams based on the stock symbol. And after that, what we are doing, every time we get a new market event, we want to check, and these time values here can change. This is just for the demo. Basically, we look on all the stock events. We have 10 minutes before the event happened and 10 minutes after that, and then we create a time window. And what we're trying to do here is an analysis. This is a process window function. What we're trying to do here is identify the impact, the cumulative impact and the actual price change into the stock symbol, like how that market event actually had the actual impact that that market event had on our price. So if I go and run this here, and because it's infinite source, it's a finite source, it's going to exit. We can see here we have a few results. And basically on the product launch, we can see that, for example, it has a good positive impact, and there is a huge, a big price change. The next job we're going to see is the price spike detection. And this application is designed to monitor in real time the trading orders and identify significant price increases for specific stock symbols within defined time windows. So basically we're using Flink's complex event processing library here, and the job detects patterns where a trade order is followed by another trade with for the same stock symbol, with the price increase exceeding a specific threshold within a 5-minute interval. So as you can see here, we have our source, and then what we are doing is we define our pattern, and we have the threshold here, and we are trying to check if there is actual a big change in the price, and all these things that happen within a window of 5 minutes. So if I go and run this job, and this job actually consumes from Kafka, I need to do here is add the provide dependencies for my job, and go and run this again. Now this is the good thing with fake data. This is normal. I forgot there is some error connected to my brokers. Let me check this. Actually, let me try and run this again. There must be some networking issue. Yes, this is the good thing with sample data, because you know the prices are creating a random, so you can see a lot of price spikes are being detected for various stock orders. So I'm going to stop this, and let's see the third job, and this is the rapid trade detection. And this job here, what it actually tries to do is, again, it uses complex event processing with Flink to detect if a trader executes multiple trades within a short time interval. And additionally, the system enriches the trade events with the trader details to get the information. So as you can see here, we have the trade stream, which is basically the trading orders, and we have the information about the traders. Here we're running a key buy on the trader ID, and then basically we are connecting the two streams together, and basically for each incoming trade order we enrich it with the trader information, and then basically using complex event processing we try to identify that if we spot like trading from a trader making at least basically three trades within 5 seconds, then we want to issue an alert and be alert of that, so we are aware of it, and you know, just see if we want to further investigate or not. So I'm going to run this job as well, and this is going to exit because again here I'm using sample data. And if I check here, we see that we get two alerts for the same user. Now, the last job, and probably the most interesting one, is about the smart trade execution. And the objective here is to dynamically manage trade orders by executing or delaying them based on real-time stock price movement, thereby minimizing the impact of the market volatility. So what happens here basically is that in high frequency trading environments, executed large trade orders during periods of high price volatility can lead to unfavorable outcomes such as increased transaction costs or suboptimal pricing. And in order to mitigate these risks, it's essential to monitor stock price fluctuations in real time and make informed decisions on whether to execute, delay, or cancel the trade orders. So what we're doing here is that we have a stock source and a trading source. We're creating stream out of those, and again we're running a key buy here on the symbol, and this is the interesting part here into this key co-process function. So basically we combine the trade orders and the stock streams based on the stock symbol, as I said, and then here we make use of two states. We maintain the most recent stock price and any pending trade order using stateful processing capabilities given to us by Flink out of the box. What we're trying here and do is calculate the change between consecutive stock prices, and if the price exceeds a predefined threshold, for example a 3% or a 5%, we consider that there is market volatility. And what we're doing here, we also make use of timers. And if volatility is detected, we set timers, for example, in 5 seconds here, to delay the trade execution, allowing the market to stabilize. And upon the timer expiration, we reevaluate the price movement to decide whether to execute or cancel the pending trading order. So this is what the code does here. You can also see the on-timer method here and how it is implemented. So what we're going to do now is I'm going to take this job, and because we have seen various jobs, see how we can also run them in a more real production setup, let's say. And the easiest way to do it is using the Ververica cloud. You can sign up and get credits to try it out for free. This is the overview page here. So what I'm going to do first is go back to my examples here and clear this thing, and I'm going to do Maven clean package to create an executable jar file for my job here. So now I'm going to go back to the Ververica cloud here, and I'm going to go under artifacts, and I'm going to upload the jar file that I just created. And let's wait a little bit for it to upload. What I'm going to do in between, go here and copy the name. Okay, so now we can go under deployments here. And what we want to do is create a new deployment from a jar file. And let's call this smart trade execution, and I'm going to use this engine here, my jar file, and this should be com.ververica.apps and the smart trade execution. I'm going to leave the rest as they are, and I'm going to hit deploy here. Now on my cluster here, let's go and edit these configurations. Let's start with 2 CPUs for the job manager, for the job manager memory, and I'm also going to give 2 CPUs to my task managers and 4 GB of memory to each. Now the parallelism for my input topic, it's 5, so I'm going to go with the 5 and also add 5 task slots per task manager. I'm going to leave the rest as it is, and I'm going to hit start here. And if I want, I can also configure autopilot that so when I deploy my job, it just keeps track of various metrics and auto scales my job as it is required. And it has different strategies, the stable and the adaptive. I'm not going to use it for this particular demo, but know it's there and it's really useful if you don't know how to really size your job beforehand. So I'm going to click start here. And seems like I forgot, let me cancel this actually. I forgot to click save here. So I'm going to add the same. And 4 here, 5 and 5, and make sure to click save here this time. So with that, and since everything has been updated, I'm going to wait for a bit as this is being cancelled. Let's give it a few seconds. And now I'm going to hit start again. And this time I didn't forget to click the save button. So you can see how the resources and the changes on the resources have taken effect. So right now I'm waiting for my job to start. Let's give it a few seconds here. And you can also see the events and how everything changes, and here it notifies you that it is waiting for the cluster to become ready and the different operations that take place. The job was successfully started, so I can go here to status now and see my job is actually start running. As soon enough as you see the process records here. And I can see that my job starts processing the records. So now what I can do, because we are printing all these things on screen, I can go here with the diagnostics. Actually, I want to go here on the diagnostics and let me figure out on the STD out. If I search, I am on the job manager and to go to the task manager, sorry. And if I go to the STD out, I should see that I'm receiving various orders, and from time to time I can see that there's price volatility that is being detected, and for specific orders it actually pauses the execution. Pausing the execution, so at some point I should see either executing orders or cancelling orders, and there are so many events taking place there. So let's see. Seems like there's no more output here, but basically if you go around and play, you should see that some events are either being cancelled based on the volatility, or the orders are actually being executed. So I hope you found this video useful. This was about to give you a better understanding on how streaming data platforms and stream processing can be used in trading environments. We saw some sample applications, and there is also provided playground. Then the GitHub link will be on the comments in the video, so if you want you can go and play around, experiment and create some applications yourself, and of course try them out on the Ververica cloud, use the platform, and yeah, I hope you like it. So thanks for watching, and see you.